No, actually, okay. Okay, first, one at a time, huh? One at a time. So the first speaker is representing the professors of the University of Helsinki. He's Barry Gills, professor of development studies. He is a chief of editor-in-chief in academic journal of Globalizations. He has written published widely on world systems theory, international political economic, global studies, development studies, the politics of resistance, and most recently about climate emergency. He's one of the founding members of this EXALT initiative and a member of HELSUS. Welcome, Barry.
Thank you. Thank you for coming. It's a very serious set of data that I want to present first. Some of it you may be familiar with already, perhaps not. And that's why I feel compelled to start by showing you some of it. I'll just start with the observation which I believe to be true, which is that we are, all of us, and everyone on the planet, and all the other species, living in an unprecedented historical global climate emergency, in which the risks are already very high and are steadily increasing ever more rapidly. But we, humanity, are not yet acting as if it is an emergency. Yesterday, the BBC in Britain led with headline news from 3 authoritative agencies who have measurements that the past 20 years have been the warmest ever recorded in a 170-year series of measurements, the available data, and that they continue to get warmer, and they expect 2020 to be even warmer than the previous years. Despite all the efforts to reduce greenhouse gas emissions and carbon emissions, specifically, that have been undertaken in the past, say, 2 decades, nevertheless, greenhouse gas emissions and carbon dioxide, CO2 in particular, emissions have risen annually, and they have cumulatively risen, as if we had done nothing so far to reverse the trend. So, I want to begin with a bit of science. I mean, at present, even if all of the up-to-date current commitments to the Paris Agreement are met by all the parties, we are still locked in on course, if nothing else changes, to 3 degrees plus heating. Some say 3.5, some say even higher. A great deal of warming or heating is locked in. The Paris commitments so far are inadequate, and certainly inadequate to keep global warming to 1.5 centigrade, as we need to do to avoid rather calamitous results. Now, I'll show you 5 slides from current science. This was produced by Will Steffen at the Stockholm Resilience Center and our team, a large team. It was published in the Proceedings of the National Academy of Science, a very prestigious journal. It has had a huge impact around the world, including to activists. This is simply to start to show you that they have coined this term, hothouse Earth. We have been in a stabilized Earth condition for all of the 12,000 years since the ending of the last ice age and the beginning of agriculture and the onset of civilization, and as we understand it. And that was a stable system which allowed us to flourish and expand over the planet, expand our population. We have now, especially, by the way, since the Second World War, or even especially since the past 3 decades. In the past 3 or 4 decades, we have released half as much carbon into the atmosphere as it was ever released by us into the cumulative amount. So things have been very much going out of control in the last 3 decades, to have destabilized the Earth system, to have destabilized the planetary climate system. So the great risk there is we are now at the turning point, and this decade is determining of the future. And in fact, the next 5 years are determining of the rest of the decade. To change trajectory, as Stefan et al. Have mapped out, we are there at the turning point. We can turn towards stabilized Earth, re-stabilize, or if we fail, there's the real possibility, which many other scientists are also endorsing the idea, including Rostrom et al. In Nature just recently, trying to summarize the same scenario, the same problem, which is that we would actually go into a state change in Earth dynamics, Earth system dynamics, which would be, for all intents and purposes, irreversible. And if we enter into that irreversible pattern, there will be runaway warming beyond 3, beyond 4, possibly beyond 5, 6, 7, 8. The models all differ, all depending on one key factor, which is, as David Wallace Wells has said in his best-selling and excellent book, The Uninhabitable Earth, A Story of the Future, in which he tries to compile all the current science on all the vectors that matter, saying that there's one element, one variable that is the most uncertain in all the models. None of the models are perfect. And that is us. That is what human beings will do in the coming years, particularly in this decade, most especially. And that will be, in effect, the determining variable of the eventual outcomes. It is dependent on what we now do to radically reduce greenhouse gas emissions locally, nationally, regionally, globally. If we do not, we can anticipate what will happen, which a great many scientists are saying very loudly will be a catastrophe. The key thing we need to understand, and that both the Stefan article and the Rostrom recent Nature article point out, is that we do not understand each of the tipping point zones on the planet as well as we might want to. We are racing against time to do so, but data doesn't come easily. And then what we least understand is the interaction between them, which we know is happening, and that they may be accelerating one another rapidly. And so the thing you need to understand, for example, in our region here, where we are right now, is that as the polar ice sheets retreat and melt, and the Arctic region heats at a much faster rate than the rest of the planet, which it does already, then as that happens, it warms the area and warms the permafrost. The permafrost contains as much carbon and more as we've already released in total in all of human history, as well as potential releases of methane, which is far more potent, especially over 20 years, perhaps 80 times more potent over 20 years, less so over 100 years, than CO2 is. Science on the release of methane is still tentative, but there is an interaction. And as the ice retreats, the albedo effect of reflection decreases, the permafrost warms, it thaws, the microorganisms get busy, they release more carbon dioxide and more methane, which heats the area more, which means the ice melts more. And it also begins a process of drying and vulnerability of forests, and it releases wildfires. And wildfires, of course, is another area that is studied globally and is very worrying. So now, I think that's shown you a bit of that. We as a species, this is not a perfect metric, none of them are, But this shows you, this is the day upon which we as a species have exceeded the normal carrying capacity of the natural ecosystems of the planet to regenerate the resources upon which we rely to live. We have been overshooting it at an increasing rate. In other words, we are now using 1.7 planets of resources, but we should be using 1 planet. That is overconsumption. And of course, that involves global inequality, global climate inequality, global economic inequality. The top billion in the world account for something like more than 2/3, possibly even 80% of the pollution that is warming the planet. So there's that issue that can never be escaped between the richest on the planet and the poorest on the planet, who suffer the most vulnerability but have contributed least to the problem. So this, the last one, is taken from a study which tries to model possible trajectories. The one thing I want you to take away from this before I just end this science section now is that the reduction in greenhouse gas emissions, which includes nitrous oxide, methane, carbon dioxide, has to be radical, and the scientists are more or less agreed about how radical that truly is, and they're now saying the current advice is that we must, humanity must achieve a 7% plus per annum reduction in our emissions starting now. Now, the last time that that happened in a major industrial economy was the collapse of the Soviet Union. That should give you an indication of what's involved. So to treat this as an emergency means that we must, and if we are guided by science-based evidence and targets, then we know what we must do in order to avoid hothouse Earth scenario becoming true. This is a radical, radical change in the organization of our material and social life. Nothing less is implied. And that has to be understood and accepted. That is because it is true. Unless you want to reject the edifice of contemporary science, which I don't advise you to do. So now, the university, to come to the point. I am advocating that what it will take to do this that I've just indicated, radical, immediate, and ongoing, basically permanent reductions in our emissions to reverse the trend towards catastrophe, requires a societal-led approach as well as a governmental-led approach in tandem and in cooperation with each other. In other words, the responsibility for all falls upon all. And all entities that have a resource budget, that can do planning, that have global supply chains, are in a situation of moral duty to do absolutely everything they possibly can to put in place science-based climate emergency emission reduction plans and implement them with all speed and seriousness. And that takes resources, priorities, reorientation of resources. Of course, universities are excelling in research. No one is challenging that. We need to benchmark the best in the world in our own set of institutions. There is a program I advise you to look at, or I suggest that you should look at later after this, which is called Cambridge Zero, a comprehensive and ambitious standard-setting program by Cambridge University in Britain, which, by the way, some people seem somehow to think is a fairly good university. We can benchmark against them and do what they are doing or do even more, and also make common cause with them and other such universities who have committed to the same. What does this imply? Well, the climate emergency has to become a central governing strategic principle embedded in all activities of the university and all future decisions that are made about the allocation of resources, procurement, the estate. In all ways, it is a comprehensive program in which all aspects of the university would be involved, and all aspects of the university would empower themselves, all staff, all students, all units, all faculties, every aspect, the administration, the estate, everything, would then examine everything they do and find ways, creatively working together, ongoingly, never-endingly, in order to find real ways to reduce emissions. I think it's no less than that. That is extraordinarily ambitious, but it is what is, in my view, objectively required. And it will involve all of us in an open, democratic, collective consultation, which I hope we will form, a kind of open assembly of this university, and everyone can be involved and everyone can contribute. Thanks very much.